Welcome to our comprehensive guide on fiber optic splicing and testing. As we delve into this fascinating world, let's start with the basics. Fiber optic cables are not your ordinary cables. They're made up of thin strands of glass or plastic, each known as a fiber, which transmit data at lightning-fast speeds using light signals. These fibers are protected by an outer layer, ensuring their longevity and performance. What makes them a marvel of modern telecommunications is their ability to carry vast amounts of data over long distances. This is achieved by transforming electrical signals into light, which then zips down the fiber, carrying information from one point to another. It's this incredible capacity and speed that has made fiber optic cables the backbone of our interconnected world. Now that we've laid the groundwork, let's dive deeper into the process that keeps these data highways functioning. Now, let's talk about splicing. Fiber optic splicing is the process of joining two fiber optic cables together. The need for this procedure arises when we need to extend the length of existing cables, repair any damages, or connect them to different pieces of network equipment. This is a delicate operation that requires precision and expertise. In the telecommunications industry, the preferred method of splicing is fusion splicing. This process involves the precise alignment of the two fibers that need to be joined. Once aligned, an electric arc is used to melt and fuse the ends of the fibers together. The result is a seamless connection that allows data to flow uninterrupted from one fiber to the other. But before we can even think about splicing, the fibers must be prepared. This involves stripping off the protective outer layers of the fibers, revealing the thin strands of glass or plastic beneath. It's a delicate process that must be handled with care to avoid damaging the fibers. Once stripped, the fibers are cleaned meticulously to remove any dust or contaminants that could interfere with the splicing process. With the fibers prepared, they are then carefully aligned and inserted into the fusion splicer. This device uses an electric arc to melt the ends of the fibers, fusing them together. The alignment must be perfect to ensure an optimal connection. After the fibers have been spliced, we can't just assume everything went well. Each splice must be inspected to verify its quality. Specialized equipment is used to examine the splice, looking for any imperfections that could affect the performance of the cable. Even the smallest flaw could lead to signal loss or other issues, so this step is crucial. After splicing, it's essential to inspect the connection to verify its quality. This is done using specialized tools that can detect even the slightest imperfections. Any issues found at this stage can then be addressed before the cable is put into use. And there you have it. That's the intricate process of fiber optic splicing. It's a delicate operation that requires precision and expertise, but when done correctly, it allows for the seamless transmission of data over long distances at incredible speeds. Now, let's move on to testing. Fiber optic testing is a vital step in the process of splicing and cable installation. It's the quality control checkpoint that ensures the fiber optic cables are working at their optimal performance. And it's not just a one-time thing. Testing is a continuous process that helps maintain the health of the network over time. So what exactly are we testing for in these fiber optic cables? Well, several parameters are assessed during the testing phase. These include attenuation, reflectance, and dispersion. Attenuation refers to the loss of signal strength as it travels through the fiber. Reflectance measures the amount of light that is reflected back towards the source, and dispersion is the spreading of the signal over time and distance. One common test is the attenuation test. This test measures the loss of signal strength as it travels through the fiber optic cable. In simple terms, it's like checking if your whisper can be heard clearly at the other end of a long tunnel. If the attenuation is too high, it could indicate a problem with the cable or the splicing, which may require further investigation. Another crucial testing tool is the optical time domain reflectometer, or OTDR. This device provides a detailed analysis of the fiber optic cable. It can measure the length of the cable, identify the location and loss at each splice, and detect any potential faults or breaks. Think of it as the cable's health report card. Once the testing is complete, technicians analyze the results to identify any issues. Depending on what the tests reveal, they might need to adjust the splice, fix a break, or even replace a section of the cable. It's all about ensuring the cable meets the performance standards and delivers a seamless flow of data. In the world of fiber optics, testing is not just about identifying problems, it's about preventing them. It's about ensuring that the magic of light-speed communication continues to revolutionize our lives. So the next time you're streaming a movie or video, chatting with a friend halfway around the world, remember that it's all made possible by meticulous testing and maintenance of these slender strands of glass. Once the testing is complete, technicians analyze the results to identify any issues and make necessary adjustments. Documentation is a vital part of the process as it provides a record of the splicing and testing procedures performed. It's like the DNA of the entire operation. Every step taken, every test performed, and every result obtained is meticulously recorded. This isn't just paperwork, it's a roadmap for future reference, a guide for troubleshooting, and a blueprint for ongoing maintenance. In the realm of telecommunications, accuracy and precision are paramount. And this accuracy extends beyond just the technical aspects. It involves maintaining a clear, detailed record of each operation. This documentation serves as a testament to the quality of the work done, ensuring that the high standards of fiber optic splicing and testing are consistently met. And there you have it, a comprehensive overview of fiber optic splicing and testing. By meticulously documenting each step, we uphold the integrity of this intricate process, ensuring optimal performance and reliable connections. We're not just making connections, we're building the infrastructure for the digital age.